Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to the Daily Check-In for November 3rd, 2020. It's Tuesday, which means it's Terraform Tuesday. And this week, we are going to be continuing our journey with Terraform and Boundary with part 2 of the series. In the previous video, and I'll put a link up here somewhere, maybe this side, I'll put it there, to the previous video. We looked at how you can take HashiCorp Boundary and you can configure it using the Terraform provider, and that was the dev instance of Boundary running locally. Now we're going to kind of change that a little bit, and we're going to look at how you can use Terraform to deploy Boundary on Microsoft Azure. That's what we're going to look at. And this video, we're just going to look at the overall architecture that's going to get deployed. And then in a future video, we'll actually get into the full Terraform configuration of everything that will be deployed. We'll actually get the deployment going, and then we'll use that provider to then configure Boundary now that it's running on Microsoft Azure. But that will be the second video. This one, we're just going to go over the architecture. And it's pretty interesting. So stay tuned for that. Before we get into that, I want to check in with you. And this is really important because it is Election Tuesday. It's a big day. A lot of people are feeling stressed. And I want to make sure that you, yes, you, I'm talking to you, you are taking care of yourself, because that is so important right now. I know we're feeling stressed. I know it's a difficult time. If you're not taking proper care of yourself, you can't take care of your loved ones. You can't do anything. You're just too stressed out. So I know last week I took the whole week off as just a mental health break, which explains why there was no video last week. It was something that was very necessary for me. And if you are feeling that stressed out moment and you are able to do something to take care of yourself, please take a moment and do exactly that. Okay, so pause the video. I don't mind. Go do the thing and then come back whenever. Okay, now let's talk about Terraform and Boundary. Now, if you go to the Terraform documentation site and you dig through a little bit, you will find a reference architecture for AWS. And that's cool. Like, you can deploy it to AWS, and there's a whole GitHub repo that has Terraform configurations for you to get it deployed and then configure Boundary with Terraform. That's awesome. But you know what? I'm a Microsoft MVP in Azure, and I felt like it was my duty to get this thing deployable on Microsoft Azure as well. So that is what I worked towards. And, you know, there's some things that you can do in Azure that are a little bit different than AWS. So let's review the overall architecture and see how I put this bad boy together. All right, blank screen, but trust me, we're going to start adding some items here. And the first thing that we'll start with, because this is Azure, is we need to start with the virtual network, aka a VNet. So let's go ahead and do that now. There's our virtual network, or VNet. Now, something you might not know about Azure if you come from the world of AWS is when you create a subnet in Azure, you don't need to specify a zone. Their subnets span availability zones. So we are going to create a single subnet for our controllers. Now, if you remember from a previous video, I talked about the architecture of Boundary. And Boundary starts with controllers. Controllers provide the authentication for the user who wants to access something through Boundary, and they also handle the management of the hosts and the host sets and the policies and the groups and all that kind of good stuff. They're the brains of Boundary, as it were. So we're going to have a subnet specifically for controllers. And then we're going to create a second subnet that's specifically for the worker nodes. And if you remember, the worker nodes are what actually connect to those back-end servers, virtual machines, containers, whatever they are. So when you create your proxy connection through Boundary, that's actually going to the worker node, and it handles proxying that connection. Now, I did say it's going to connect to something, so we're going to create a back-end subnet for whatever servers you might want to connect to. It doesn't just have to be this one subnet, though. You could have multiple subnets in this virtual network. You could peer virtual networks and then have subnets in those other virtual networks that have backend servers you want to connect to. You could do all kinds of crazy network architectures, but trying to keep it simple for this reference. Okay, now in the controllers subnet, we're going to place controller VMs. My configuration that I've built so far defaults to 1, but you can do 3, you can do 5. It's probably going to be an odd number. That's the recommendation. Generally speaking, 3 is probably going to cover you for however big you're going to get, because the controllers aren't handling all the proxy requests. They're just doing the initial authentication and the host catalog. So you'd think 3 is probably a good number for handling that sort of thing, especially if you size your virtual machines appropriately. Down in the workers, you're going to have worker VMs. And for this, I put a static number as well. But the more I think about it, the more I think it might actually make sense to use virtual machine scale sets for the workers, because that way you could monitor the number of requests that are coming into proxy and scale up your workers to meet the demand of those requests, and then scale them back down when you don't need that many workers because they're just not being used. That would probably make a lot of sense. So like V2, I'm probably going to end up doing that. All right. Now, the controllers and the workers both have a network security group assigned to them, and that's going to control what has inbound access to those virtual machines. For controllers, generally speaking, what needs to talk to them? The clients need to talk on 9200, and the workers need to talk to it on 9201. So that's going to go into that NSG. The workers need to accept connections from clients, so that'll be 9202, and that's pretty much it for inbound rules for the workers. I've also created application security groups, and that's basically like labels assigned to the VMs, and you can use those groups in inbound rules and other network security group rules. So for instance, on the controllers NSG, I say workers that belong to the ASG for workers can talk to controllers on 9201. We'll see that in a moment. On the backend side, you're going to have some backend servers, and then I've assigned a network security group to the backend subnet saying allow any from workers, and that's it. And you can be more prescriptive with additional network security groups on the individual VMs, but it's good to just have a subnet level NSG as well. All right, now what other components do you need for your boundary deployment? Well, you need a KMS of some kind. And in the AWS reference architecture, you use the AWS KMS service. But in Azure, you're going to use Azure Key Vault. What goes in that good old Key Vault? Well, you're going to have a number of keys and a self-signed certificate that gets generated by Terraform. The certificate will be installed on both the controllers and workers, and it'll be what they present to the client when it connects. And I'm using a self-signed certificate that's generated on Key Vault, but you could upload your own certificate if you have like a public cert that you want to use for this. The 3 keys, there's a root key, which is used by the controllers as the main encryption key. There's a worker key, which is used by the workers and controllers to authenticate those workers. And then finally, there's a recovery key. And the recovery key is used to do the initial configuration of the controllers or a recovery configuration if no other authentication mechanisms are available. And we'll get into that when we do the actual deployment. The other thing you need is a database backend for the controllers to talk to. And in this case, we're going to be using the Azure Database for Postgres service, because right now Postgres is the only database type supported by Boundary. Maybe Microsoft SQL will be supported later, but honestly, it doesn't matter. It was very easy to utilize this service rather than spinning up my own Postgres server. So those are the components. Let's get into the connectivity a little bit. Now, for Key Vault, you can set up firewall rules in Key Vault to restrict what can talk to that Key Vault. And I added my own client IP because I need to be able to interact with that Key Vault. And I created service endpoints on the controllers and the workers. And those service endpoints have the Azure Key Vault service enabled on them. And in the Key Vault configuration, I'm saying allow connections from those 2 subnets. So those 2 subnets can talk to that Key Vault, but anything else in the world can't, and that's important. You can also add service endpoints for Postgres. And so there's a service endpoint for Postgres, and that allows the controllers to connect to that Postgres database, but I can have firewall rules that say don't allow connections from anything else besides these controller servers. So that is the configuration for the controllers and for the workers talking to Key Vault and Postgres. What else do we need? Well, we need to be able to connect to those controllers and workers. And so there is an Azure standard level load balancer on the front end of this thing with a public IP address assigned. And it is going to have a load balancer rule for port 9200 going to the controllers. And it's going to have a separate rule for 9202 going to the workers, because those are the standard ports used by Boundary. You could obviously change those, but I don't really see a reason why you would. Okay, so those are the two rules that exist on that load balancer, as well as health checks to make sure that the ports are listening on the controllers and workers. And the network security groups have to allow traffic from anywhere, or you can be more prescriptive and say only certain public IP addresses can connect to my controllers and workers. The workers themselves need to talk to the controllers, and they will do that through 9201. So there's going to be an additional rule in the NSG for the controllers allowing for that communication. And then lastly, the workers need to talk to your backend servers, and it could be SSH, it could be RDP. Just for the sake of simplicity, I said anything, any traffic from those workers, ASG, can talk to anything on the backend subnet. And then, like I said, you can be more prescriptive on the individual virtual machines. So that is the complete setup. You'd have a client on the front end that talks to the public IP address on that load balancer. It can authenticate to the Boundary controllers, request a session with one of the backend servers, and then connect to one of the worker nodes to proxy that connection to that backend server. That's the full-blown reference architecture for Boundary running on Microsoft Azure. Like I said, there's probably some tweaks that I need to make, but the Terraform configuration is ready to go. If you want to take a look at it before the next video, you can always go to my GitHub repository for Terraform Tuesdays. That will be down in the description, so you don't have to try to find it. And that'll pretty much do it for me for today. As always, I want to thank you for watching. If you don't mind, if you'd like to subscribe to the channel and maybe share it with someone else, that is obviously much appreciated. That's all I have for today. Until next time, stay healthy and stay safe out there. Bye for now.